Hi everyone, welcome back to my YouTube channel. In today's video, we learn about the zener diode, its working principle, and also we discuss about the applications of zener diode. And at the end of this video, we'll discuss a mind map to this zener diode so we can easily remember. So don't skip the video. Please try to watch until the end. So now we'll start the definition for the zener diode, and then we see the construction, and then we see the VI characteristics of the diode. So zener diode is a special type of semiconductor diode that is designed to allow the current flow under the reverse bias condition also. Means when you observe means in the normal PN junction diode under the reverse bias it can't able to work. Means if we operate a diode under the reverse bias after breakdown it will the diode get completely damaged. So that is the drawback of normal PN junction diode. So to overcome that drawback they specially designed the zener diode. So under this zener diode so these can easily operate under the reverse bias condition. So this zener diode is a special type of semiconductor diode that can use to operate under the reverse bias condition. So in the construction, the main difference between the normal diode and the zener diode is doping concentration. Means in the normal PN junction diode, we have lightly doped. So by the lightly doping, the width of the depletion region is thick. When the width of the depletion region is very large, we require large amount of voltage to get breakdown. So to overcome that, what they done in the construction of zener diode, so they done doping level, they increase the doping concentration. So by increase the doping concentration, the width of the depletion region will get decreased and it require less voltage to get breakdown. Means in the normal diode it requires a large amount of voltage to get breakdown, so by applying that the diode get damaged permanently. So to overcome that they are using the small voltage by doping concentration, and this is the construction of a zener diode. See according to this construction, and not only this circuit diagram, in any circuit diagram the ammeter should connected to the device in the series. And coming to voltmeter, the voltmeter should always connected in parallel. So when the zener diode is connected under the reverse bias, so when the reverse voltage reaches the zener diode voltage, then it will start conducting current and the voltage remain constant. Means for example, let us assume the zener voltage is 5 volts. So when we apply the reverse voltage, that reverse voltage reaches to 5 volts. Then that voltage become constant, then only the current will conduct. So this is about the working principle, and now we see the VI characteristics of the xenon diode. So here I want to say one thing is the xenon diode is very special semiconductor device because means when xenon diode is used to operate under the forward bias condition, so it will act as a ordinary diode. So the flow of current in the forward bias is same as the normal PN junction diode. So coming to reverse bias, when we apply under the reverse bias condition, it will maintain the constant voltage when it reaches the zener diode and it will start conducting. So when you observe under the reverse bias, here it maintaining the constant voltage. So this is the reason, and this zener diode is also called as the voltage regulator. So what is mean by voltage regulator means even though the changes occurs in input, it will maintain the constant under the output. So this is the mind map for the zener diode. So before exams you can go through it once, and only in the less time you can remember everything. So first we see the definition. So in the definition what they given, so it is a heavily doped semiconductor device and which is operated under the reverse bias, and this zener diode which is used as the voltage regulator. So coming to the working operation, so it as we know zener diode is operated under the reverse bias condition, and it is based upon the breakdown mechanism. Means it will break down according to the avalanche breakdown or zener breakdown. In next video I will explain about the avalanche breakdown and zener breakdown, and I will also explain the major difference between the avalanche and the zener breakdown. So this is working principle, and coming to the VI characteristics. So as we know under the reverse bias the voltage is constant and it has a sharp breakdown. So in forward bias, it will act as a normal PN junction diode. So coming to these applications where we using this zener diode means we are using this zener diode in voltage regulators, clipping circuits and limiting circuits. Coming to the advantages, what are the major advantages of this zener diode means it will use as voltage regulation and dual functionality, compact in size. And coming to disadvantages, limited current handling, low efficiency, temperature sensitivity and voltage limitation. So this is very easy to remember. So in short time we can remember everything about the zener diode. So this is all about the zener diode, its construction, working, applications, advantages, disadvantages. All are covered in this video. So in next video we will see the major difference between the avalanche and the zener breakdown. So till now the video is completed. Thank you for watching and keep supporting. Don't forget to subscribe my YouTube channel. Thank you for watching. See you in the next video.